There's an intruder in our solar system, and it's behaving like nothing we've ever seen before. Named 3I Atlas, this visitor from the depths of interstellar space is systematically breaking the laws of physics, forcing scientists to question everything they know about the cosmos. Imagine a comet that shoots a jet of energy straight toward the sun instead of away from it. Imagine a cosmic object made of metals that, here on Earth, we only get through industrial processes. And imagine its trajectory is so perfectly aligned with the planets that coincidence seems like too weak a word. Astronomers worldwide are at a standstill, torn between explanations that don't fit and a truth that many hesitate to say out loud. Could 3I Atlas be a bizarre natural phenomenon, or the first real evidence of extraterrestrial technology cruising through our cosmic backyard? Get ready. Today, we're going to unravel every anomaly surrounding this enigma and confront the question that could forever change our view of the universe. What exactly is visiting us? The universe is a stage for grand events, but few have been as baffling as the arrival of 3I Atlas. First detected in early 2025, it was initially classified as just another interstellar comet, the third ever confirmed in our history, after 1I Oumuamua and 2I Borisov. But that simplistic label fell apart on July 21, 2025, when the Hubble Space Telescope made an observation that shook the foundations of astrophysics. The captured image showed a jet of gas and dust coming from the object, but with a feature that violated everything we know about comets. The jet was pointed directly at the sun. To grasp the magnitude of this anomaly, you need to know how a comet works. Comets are bodies of ice, rock, and dust that heat up as they approach the sun. The ice sublimates, turning directly into gas, and this release creates a temporary atmosphere called a coma, plus the famous tail. Driven by solar radiation and wind, a comet's tail always points away from the sun, like a flag blowing in the wind. What Hubble saw in 3I Atlas was the opposite, a perfectly collimated jet with a ratio of 10:1 between length and width, stretching over 6,000 kilometers directly toward our star. The scientific community's first reaction was skepticism. The initial hypothesis was that it was an antitail, a rare optical phenomenon that can happen when Earth crosses the orbital plane of a comet, making heavier dust particles appear to point toward the sun from our perspective. However, later calculations ruled this out. The angle between 3I Atlas, Earth, and the sun wouldn't allow for that type of illusion. The W.M. Keck Observatory in Hawaii confirmed the phenomenon in August 2025, recording the same bright and persistent jet. The jet was real. Harvard astrophysicist Avi Loeb, one of the most prominent voices in this debate, described the anomaly memorably, saying that seeing the jet was as anomalous as seeing a cat with its tail coming out of its forehead. The inevitable question arose: what force could generate a stream of material against the immense pressure of the solar wind? A few natural hypotheses were proposed. One suggests that a burst of very large and dense dust particles with enough inertia could resist the solar pressure and form the structure. Another theory involves interactions with local, complex magnetic fields around the object's core. However, no physical model has been able to accurately reproduce 3I Atlas's behavior. Loeb and his colleague Eric Quito published a paper suggesting that the precise geometry and lack of dispersion in the jet indicate a controlled or at least highly focused ejection, not the result of the chaotic, random process typical of cometary sublimation. This first anomaly was just the tip of the iceberg, a calling card for an object that, with each new observation, appeared even stranger and more challenging. If 3I Atlas's dynamic behavior was unsettling, its chemical makeup brought nothing but perplexity. Using high-resolution spectroscopy instruments like the Keck Cosmic Web Imager, astronomers analyzed the light reflected from the jet and coma to decipher its components. The result was unprecedented: intense emissions of nickel, a heavy metal, but with a complete absence of iron. In all known stellar nucleosynthesis processes, the cosmic furnaces where elements are made, such as supernova explosions, nickel and iron are produced together in relatively similar proportions. Finding pure nickel with no iron is something that simply doesn't happen in known natural environments. On Earth, the only way to get nickel that pure is through sophisticated industrial methods, like the Mond process, which uses volatile nickel tetracarbonyl to separate and purify the metal. Avi Loeb was quick to point out the analogy, not to say 3I Atlas is artificial, but to highlight how extraordinary its chemistry is. The mere similarity to an industrial process sparked a deep debate among scientists. Are we witnessing an unknown chemical reaction that happens in exotic interstellar conditions, or something deliberately imitating a manufactured product? The weirdness didn't stop there. The James Webb Space Telescope, JWST, confirmed in the mid-infrared that the expelled material S composition is radically different from that of a comet. It estimated that it releases about 150 kilojoules of material per second. 87% is carbon dioxide, CO2, 9% carbon monoxide, CO, and only 4% is water, H2O. Solar system comets are basically dirty snowballs rich in water. 3I Atlas, on the other hand, is a carbon-rich, extremely water-poor body, indicating it formed in an environment much colder and chemically distinct from the nebula that gave rise to our solar system. To add another layer to the mystery, traces of cyanide, CN compounds, were detected. Cyanide, though toxic, is a crucial prebiotic molecule. It can react under the right conditions to form amino acids, the building blocks of proteins and life as we know it. This means 3I Atlas carries the same kind of chemistry that may have seeded life on Earth billions of years ago. The issue: all this chemical activity was detected while the object was nearly 3 times the Earth-Sun distance, a frigid region of space where solar heat is far too weak to trigger significant sublimation in an ordinary comet. It was emitting gas as if heated from the inside, sparking ideas of internal heat sources, such as radioactive materials. Others, like Loeb, see a controlled and efficient ejection pattern, reinforcing the idea that 3I Atlas is not just a lump of ice and rock, but a complex, active system operating under rules we don't yet understand. Every new puzzle piece from 3I Atlas seemed to contradict the last. While its chemical activity hinted at a volatile body, its movement told another story. Initial attempts to measure its rotation period produced conflicting results. Russian researchers estimated a rapid 4-hour spin, while international teams found a slower value of 16 hours. This might be explained by acceleration from uneven gas ejection, a known phenomenon. However, the regular amplitude of brightness variation suggested a structure more solid and dense than typical comets, which are usually brittle ice and dust clumps. The real surprise came when a Harvard team, Richard Cloutier, Avi Loeb, and Peter Verus, calculated its actual mass based on non-gravitational acceleration, the tiny recoil force that jets of gas exert on a comet S-core. In a normal comet, this force is enough to subtly shift its orbital trajectory. After analyzing data from over 220 ground telescopes between May and September 2025, the team found that the curiosities seen in 3I Atlas was much smaller than expected for the amount of expelled material. The only explanation: its core is extremely heavy and dense, a true cosmic anchor that barely moves despite its own jets. Calculations revealed an estimated mass over 33 billion tons, and a diameter of about 3 miles, 5 kilometers. These numbers are colossal. Three-eyed Atlas is roughly 1,000 times more massive than 2I Borisov and 1,000,000 times more massive than Oumuamua. This raises a profound statistical paradox. Models of interstellar object distribution in our galaxy predict that for each object like 3I Atlas, we should find hundreds of smaller asteroid-sized objects. Yet, we found 2 smaller ones, Oumuamua and Borisov. Then this giant. The odds of spotting something this big so quickly are extremely low. If the mass anomaly wasn't enough, 3I Atlas's path displays a geometric coincidence that triggered every alert. Its orbit is nearly perfectly aligned with the ecliptic, the orbital plane where all planets from Earth to Jupiter move. An object from deep interstellar space, after millions of years of travel, should arrive at a random angle. The chances it would enter our solar system sideways, perfectly lined up with the planetary plane, are incredibly slim. Such a combination of enormous mass and precise orbital alignment defies any accidental explanation. Loeb suggests this may be related to its origin, possibly forged in a dense part of the galactic disk through repeated collisions compacting its interior. Or, in the boldest hypothesis, perhaps its path isn't random. Maybe it's a designed artifact, moving with deliberate stability and precision, disguised as a comet. Though Loeb calls this speculative exercise, the built-up evidence makes it hard to dismiss, forcing science to face a mosaic of improbabilities beyond conventional explanations. The mystery around 3I Atlas has turned its trip through our solar system into a true global scientific hunt, with humanity's most advanced instruments aimed at it. The observation calendar is full of critical moments that could finally bring answers. The first big event comes on October 29, 2025, when 3I Atlas reaches perihelion, its closest approach to the Sun, about 126 million miles away. Here, solar heat will peak, and the object's behavior will be pivotal. If it fragments under thermal stress, as many comets do, the debris could reveal its core's composition and structure. But if it endures, remaining solid and cohesive, the idea that it's a dense, robust body, perhaps even artificially reinforced, will grow stronger. No result will be trivial. Each scenario holds vital clues. Soon after perihelion in November 2025, ESA's JUICE probe, Jupiter Icy Moons Explorer, will have a unique opportunity. As it heads toward Jupiter, JUICE will be perfectly positioned to observe 3I Atlas side-on, while it's still highly active from solar heat. This new viewpoint could help map the 3D structure of the jet and coma in ways Earth's telescopes cannot. However, the orbital geometry and distance will make data transmission difficult, delaying information until January or February 2026. December 2025 promises to be even more special. On December 19th, 3I Atlas will make its closest approach to Earth, passing about 106 million miles away. Though not visible to the naked eye, the James Webb Space Telescope and Chile's Vera C. Rubin Observatory will be ready. Webb's infrared sensitivity will enable the most detailed chemical analysis ever, while Rubin's wide view can map the full extent of the tail and the mysterious solar jet. The pursuit's climax may come on March 16, 2026. On this day, 3I Atlas will cross Jupiter's orbit. NASA's Juno probe, now orbiting the giant planet, could, in theory, get permission for a daring course change. If calculations allow and the risk is acceptable, Juno could fly through 3I Atlas's plume, letting its instruments perform the first in situ analysis of material from another star system. A priceless scientific feat. This could be the only chance to touch the visitor before it disappears forever into interstellar space. After Jupiter, 3I Atlas will become a faint point in the sky, unreachable by our telescopes, leaving behind terabytes of data and questions that will shape astronomy for decades. Each observational window is a unique opportunity to solve a mystery that might redefine our place in the cosmos. Piecing together the 3I Atlas puzzle, the result is an image that defies logic and probability. We're not dealing with a single anomaly, but with a cascade of improbable features reinforcing each other. Avi Loeb sums it up with the Hebrew word dayenu, meaning it would have been enough. If 3I Atlas only had a jet pointing toward the sun, it would already be one of the weirdest comets ever. If it only had a nickel-rich chemistry with no iron, it would revolutionize astrochemistry. If it were only colossal and perfectly aligned, it would be a statistical anomaly of the first order. The fact that it has all these features simultaneously elevates the mystery to a whole new level, forcing science to operate at the edge of knowledge. One last, unsettling coincidence adds to the list. 3I Atlas' S-trajectory in the sky points to the same region of Sagittarius as the famous WOW signal, a powerful, brief radio signal detected in 1977 and still regarded as our strongest candidate for an extraterrestrial transmission. It's probably just a coincidence, but against the backdrop of other anomalies, it deepens the enigma even further. Today, the scientific community is split into two main camps. The first and most conservative argues that 3I Atlas is a natural, though highly exotic, object. Its proponents claim it simply formed in a type of stellar environment we don't yet understand, perhaps the disk of a carbon-rich star or a dense, cold molecular cloud, where unknown chemical processes could create its unusual makeup and structure. In this view, 3I Atlas is a messenger bringing information about the diversity of planetary systems across the galaxy. Its anomalies are clues to new physics and chemistry, not alien tech. Science, by its nature, should exhaust all natural explanations before considering the extraordinary. The second camp, led by voices like Avi Loeb's, argues that the technology hypothesis, or a technosignature, shouldn't be dismissed prematurely. They argue that piling up so many improbabilities makes the chance hypothesis statistically fragile. In their view, 3I Atlas could be an interstellar probe, perhaps ancient, designed to travel the galaxy. Its solar jet could be a braking or course-correcting mechanism, its metallic core part of its structure, and its precise trajectory intentional. The precedent set by Oumuamua, with its odd shape and unexplained acceleration, had already paved the way for this discussion. 3I Atlas, with even louder anomalies, is intensifying it. For now, science remains cautious and focused on gathering data. No one's claiming with certainty that 3I Atlas is artificial, but the challenge of explaining its features naturally leaves the door open to that fascinating possibility. It might just be a bizarre comet, or the first tangible evidence that we're not alone. Either way, its silent passage through our cosmic backyard has already changed the way we look at the sky and the stars. The mystery of 3I Atlas defies everything we know, and your opinion is crucial to this debate. What do you think this visitor really is? A natural anomaly or something more? Leave your theory in the comments below. And if you're passionate about uncovering the universe's greatest secrets, don't miss out. Subscribe to the channel and turn on notifications to keep exploring with us.